Our Earth, it seems so solid beneath our feet, a steadfast sphere in the vastness of space. Yet this planet is alive, it pulses with energy, it shifts, it groans, it transforms constantly, relentlessly. This dynamism shapes our world, it creates mountains and oceans. Understanding these changes is vital. Volcanoes, they are Earth's fiery breath, dramatic expressions of its inner turmoil, windows into the molten heart of our planet. They remind us of the immense power hidden just beneath the surface, a power that can build and destroy, a power that has shaped life itself. We are drawn to study them, to comprehend them. Why do we watch these sleeping giants? Partly for safety, to protect human lives, to shield communities from nature's fury, but also for knowledge, to unlock the profound secrets of Earth's geology. This quest drives us forward. In this exploration, we turn our gaze to two of North America's most famous volcanoes, Yellowstone and Mount St. Helens. Our journey into their secrets begins now. Yellowstone National Park, a wonderland, known for its geysers, Old Faithful, Grand Prismatic Spring, rainbows of microbial life in steaming pools, bison roam free, bears wander, nature's spectacle. But beneath this serene beauty lies a giant, a colossal volcanic system, a supervolcano. Its eruptions long ago were cataclysmic, shaping continents, altering global climate. Recently, scientists have observed something. The ground in parts of Yellowstone is rising, a phenomenon we call ground uplift. Imagine the Earth taking a slow, deep breath. The surface swells almost imperceptibly. Millimeters here, centimeters there, over years. This is not unusual for such a place, but it commands our attention, our careful study. What causes this subtle swelling of the land? The science points to movements far below, deep within the Earth's crust. Magma, the molten rock, could be shifting, or perhaps superheated water and gases. These fluids, products of the magma's heat, they migrate upwards, they push, they expand. The ground above responds. How do we know the ground is rising? We don't just guess, we measure. Precisely. Scientists use an array of sophisticated tools. Satellites orbit our planet ever watchful, using radar, a technique called InSAR. They can detect tiny changes in ground level, across vast areas, with incredible accuracy. Global Positioning System, GPS stations on the ground also track movement. We also listen, with instruments called seismometers. These are the Earth's stethoscopes. They detect the faintest vibrations, tiny earthquakes, too small for us to feel. These tremors are the heartbeat of the caldera. They can reveal the movement of magma, or the cracking of rock as pressure changes. Each tremor tells a part of the story, and we sniff the air, or rather, our instruments do. Volcanoes release gases from their depths: sulfur dioxide, carbon dioxide, helium. The types and amounts of these gases can change. These changes can signal shifts in the magma system. Is it rising closer to the surface? Is it releasing more volatiles? These are crucial clues for scientists. All this data, from GPS, from seismometers. Mount St. Helens, a name that resonates. It evokes powerful images, memories of destruction. On May 18, 1980, this volcano awoke, not with a gentle sigh but with a furious roar, a catastrophic eruption that stunned the world. It reshaped the mountain, it reshaped our understanding of volcanic hazards, of nature's raw power, a day that is etched into geological history. The 1980 eruption was not a simple upward blast. The north face of the mountain collapsed, unleashing a massive landslide, the largest in recorded history. This uncorked the magma system. A searing lateral blast erupted sideways, flattening forests for hundreds of square miles. Ash plumes soared high into the atmosphere, darkening skies across distant states. A stark reminder. Today, Mount St. Helens is quieter. The landscape is slowly recovering. Life returns. But the volcano is not dormant. It is active. In recent times, scientists have detected small tremors, swarms of tiny earthquakes, originating deep beneath the scarred edifice. These are not strong enough to be felt by people, but our instruments hear them clearly. Section 5 Lessons from the Ash Revolutionizing Volcanic Watch. Before 1980, volcano monitoring was a developing science. The Mount St. Helens event was a wake-up call. It showed us how much more we needed to learn. It spurred a revolution in monitoring techniques. Scientists focused their efforts to better forecast eruptions. A new era of volcanic vigilance was born from the ash. Consider the advancements since then. They are remarkable. Section 6 Under Pressure, Probing the Magmatic Hearts. Yellowstone and Mount St. Helens, two distinct personalities in the world of volcanoes. Yellowstone, the sprawling supervolcano, Its eruptions are rare but unimaginably vast. Mount St. Helens, a stratovolcano, capable of explosive outbursts, more frequent smaller scale, yet both are connected by the same fundamental forces, the restless movement of heat and rock within our planet. Deep beneath Yellowstone lies its heart, a massive magma chamber, or rather, a complex system of partially molten rock like a colossal hot sponge. It extends for tens of kilometers. This chamber is the source of Yellowstone's famous heat, its geysers, its hot springs. And it is the reason the ground there breathes, uplifting and subsiding over time. Mount St. Helens also has a magmatic system, but it is different, likely smaller and shallower. After its 1980 eruption, it began to rebuild. Lava domes grew within its crater. This is a sign of magma slowly ascending. The recent small tremors we observed, they are likely related to this ongoing process, the slow, steady recharge of its inner furnace. The ground uplift at Yellowstone, the small earthquakes at St. Helens, these are not isolated random events. They are messages from the deep. Section 7, Sleeping Giants, Assessing Risks, Ensuring Safety. So, we see these signs of activity. The ground swells at Yellowstone, the earth trembles at Mount St. Helens. A natural question arises. Should we be worried? Is a catastrophic eruption just around the corner? The scientists who dedicate their lives to studying these behemoths, they offer a clear and reassuring answer: no. There is no indication of an imminent large eruption at either of these volcanic centers. What does imminent mean in this context? Geologists think in vast timescales, eons, millennia. When they say no imminent threat, they mean it. The current activity levels are considered normal for active, dynamic volcanic systems like these. They are like a patient's vital signs, a slightly elevated pulse, a gentle breath. Not signs of a crisis, but signs of life. These subtle signs are, in fact, crucial. They are the volcanoes communicating with us, telling us about their inner workings. The uplift and tremors are part of their natural cycles that can span centuries or even millennia. Understanding these background levels of activity is key to recognizing when something truly changes, when the signals might point to a more serious awakening. Therefore, continued monitoring is not just important, it is essential. Our networks of sensors are our eyes and ears. Section 8, The Human Quest, Knowledge, Awareness, and Our Future. The story of Yellowstone and Mount St. Helens. It is a story of ongoing scientific discovery. Researchers are like cosmic detectives, patiently gathering clues from deep within the Earth. They analyze seismic waves, they study rock chemistry, they map the hidden plumbing of these volcanoes. Each new piece of data adds to the grand puzzle, revealing more about these complex natural systems. We're also making strides in modeling using powerful computers to simulate volcanic processes, how magma moves, how eruptions might unfold. These models help us understand the physics, they help us test hypotheses, and they are crucial for improving our ability to forecast, to provide more specific warnings in the future. It is a grand challenge, but we are making progress. Public awareness and education are also vital, especially for communities living in the shadow of volcanoes. Understanding the science, knowing the hazards, being prepared, this empowers people. It replaces fear with knowledge, anxiety with readiness. Science communication plays a key role here, making complex information accessible to everyone, because we all share this dynamic planet. These volcanoes, Yellowstone and Mount St. Helens, they are not just geological features, they are teachers. They teach us about the Earth's power, its beauty, its fragility. They remind us of the vast forces that shape our world.